Welcome you all for a session on decision trees. Decision trees are machine learning algorithms which follow a tree-like structure or a flowchart-like structure. They can be used for the purpose of classification and regression. We all know that in classification we have the output variables as categorical variables, and in regression the output variables are continuous variables. Let us take a scenario of a shopkeeper who wants to organize his stall. He has a range of vegetables and he wants to categorize them into different sections. So we will help him by following the decision tree and help him categorize it. So we will introduce few notations which we will follow in the decision tree. We will have nodes, root node and the leaf node. The top of the tree, that node we call it as the root node. And the nodes on the edges at the bottom level, we will call them as the leaf node. We will make a test on each of them. So we will make use of notations known as entropy. Here, entropy is a measure of the messiness or the randomness or the unpredictability in the data set. Here, this has a multiple of vegetables, so this collection has high entropy. But here it is only oranges and broccoli, so this collection has low entropy. So this metric we will make use in our decision trees. Followed by this, we will make use of something known as information gain, which we will make use when after splitting a criteria, how much has the entropy reduced. Decision tree follows a divide and conquer approach. So we start with the root node and then we try to create branches. So which variable we will take for splitting. How to decide on that? We will make use of by information gain and entropy. So once we split that into those instances into subsets, we repeat. We repeat until all instances have the same class. We will expand on this further. We will take a simple data set known as the play tennis data set, which has the different features. We have a outlook feature, we have a temperature feature, humidity feature, and wind feature. And based on these variables, we have a decision label whether to play tennis or not to play tennis. So we have different variables and each variable has different values. Outlook variable has three sub values. It could be sunny, it could be overcast, and it could be rainy. Windy, whether it is windy or it is not windy. And what about the temperature? Is it a hot day or a mild day or a cool day? Whether the humidity is high or the humidity is normal. So the different values are yes and no for the different variables, and based on this we will start making use of the variable information gain. So information gain helps us to understand how much has the entropy reduced after we have done some splitting. Why we need to split? Because we need to understand we are forming a tree. So we need a root and then followed by that we need to have the different levels. So which variable, which feature, which attribute will follow the hierarchy. So we will make the splitting based on information gain. So we are going to measure entropy using a probability distribution, and it is measured in bits. So the formula for entropy is given few variables p1 to pn, it is minus p1 log p1 minus p2 log p2, henceforth till minus pn log pn, which can be summarized as sigma I minus pi log 2 pi, where pi is the probability of the class. So this entropy we take it from the information theory. So higher the value of entropy, it means more information content or more randomness. Correct? So now we'll just make more understanding. Suppose it is a two-class problem. There's a plus and there is a circle. So these are the two labels. Suppose we have a scenario where all the instances, all the rows, all the examples belong to the same class. Then what will be the entropy? Next scenario is when there is 50% chance. There are 6 instances and 3 instances follow the plus and 3 instances follow the green ball. Then what is the entropy? So given the formula, we know it is minus pi log pi. So here there is only one instance, so it is minus 1 log to 1, and we know that is 0. So here there are two instances, so there is p1 and p2. So p1 has half and p2 has half. So it is minus pi log pi. So it is minus 0.5 log to pi minus for p2. Again it is 0.5 log to pi log to 0.5. So which sums up to 1. So this helps us infer that when a class has minimum impurity, the entropy value is low, 0. When the class has high impurity, both the labels have equal distribution, then it has high entropy, 1. Now we will come back to our play tennis example. So we have this data set, and based on this our requirement is to build a decision tree in order to help us understand how a decision can be made. So we have these 4 different variables. We have outlook, temperature, humidity and windy. So which attribute to choose for the root node? How to make the decision? For that we will start making use of the entropy calculation. So we will start with the first variable. We will take each variable because we looked at the divide and conquer method. We start with each attribute, each feature. We will calculate the entropy and the information gain. And then based on the decision, based on the values of the information gain, we will choose the attribute to split, which we can take for the root node. The first step is we take the first variable, which is your outlook. Outlook has 3 values. It could be sunny, overcast or rainy. Sunny, overcast or rainy. So we will take for sunny how many positive instances are there and how many negative instances are there. So in sunny we have 2 positive instances and 3 negative instances. In overcast it is a single class. It is everything is S. If it is overcast we played an S. And in rainy we have 3 instances as positive and 2 instances as negative. So this is how we are going to split it. So we have 2 positive instances and 3 negative instances. In overcast we have 4 positive instances. The first denotes the positive instance and the next denotes the negative instance. So we here do not have any no, so we just mark it as 0. And in rainy we have 2 no's and 3 yes. So how do we calculate the entropy? So it is, here it is 2 by 5 and 3 by 5. Here it is 1 comma 0. Here it is 3 by 5 and 2 by 5. Why 5 as the denominator? Because here the total value is 5 and 3 instances belong to one label and 2 instances belong to the other label. Here it is 1 comma 0 because all the instances belong to one instance. So based on this we will move on. So how will we calculate? So for here it is 2 by 5 and 3 by 5. So we have to substitute in this formula. So it is minus 2 by 5 log 2 by 5 for the first thing. Then minus 3 by 5 log 3 by 5. So when we calculate we have this in bits. So this is the entropy for the sunny value of the outlook variable. Similarly for the overcast it will be 0 bits because all of them belong to the same class. You know it is undefined, but we will assume that it is 0. And for rainy it is again both of them will have the same value. So whether it is 2 yes and 3 no or 3 yes and 2 no, it will have the same value. That is why the value of S and no could be interchanged. So based on this, now if you want to find the expected information for this attribute overlook, then it is the weighted average of its children. The children are sunny, overcast and rainy. So based on these 3 children values, you are going to determine the weighted average of the attribute overlook. So which can be given as what is the information gain before splitting and after splitting. So before splitting we totally had 14 instances in the data set. The data set has 14 rows, and out of those 4 rows, 9 rows have positive instances as its output variable and 5 rows have no as its output variable. And here for Outlook we have 3 subcategories, and first subcategory has 2 comma 3 as it's 2 yes and 3 no, 4 yes, and here it is 3 no and 2 yes. So how are we going to calculate? So here we will summarize again. So here we have taken the Outlook variable. It has 3 categories, and for each of the category we have calculated the entropy. So for sunny it is 0.971 is the entropy. For overcast it is 0 because it falls under one label, and for rainy it is again 0.71 because both of them have 3 comma 2. Then for this attribute, what is the expected information? So how do we calculate the information? So for that we have to take it as entropy into the number of instances for that particular category. So why is the denominator 14? We have totally 14 instances in our data set. Out of that, 5 contribute to the sunny. So it is 5 by 14 into the value of the entropy for sunny, which is 0.971. And 14 are the total instances for overcast, and 4 is the total number of positive cases, and the entropy is 0, and it is sigma. So plus we have 5 instances for rainy, and what is the entropy? So when we calculate it, we have the expected information for the attribute Outlook. So similarly we calculate it for the entire tree. 9 comma 5, 9 is the positive instance, 5 is the negative instance. So we have the information for the entire tree before splitting as 0.94, and after splitting based on the Outlook attribute we have it as 0.693. So difference between the information before splitting and after splitting contributes to the information gain of the attribute Outlook, which is 0.247 bits. So now we have calculated for the attribute Outlook what is the information gain based on the value before splitting and after splitting using the entropy calculation. This we will repeat for all the attributes. So we will move on to the humidity attribute. Humidity attribute has 2 sub values, high and normal. So out of the 14 instances in the data set, we have 7 instances which fall under high and 7 instances which fall under normal. Within high we have 3 yes and 4 no, and within normal we have 6 yes and 1 no. So based on this we calculate the entropy, which we know the formula is minus sigma pi log pi. So it is minus 3 by 7 log 3 by 7 minus 4 by 7 log 4 by 7, which contributes to 0.985 bits. And for normal value of the humidity attribute, we calculate the information at that point as entropy of 6 comma 7 comma 1 comma 7, which is minus 6 by 7 log 6 by 7 minus 1 by 7 log 1 by 7, which is this. Now what is the expected information for the humidity attribute? So what is it? It is the number of instances under humidity for this subcategory divided by the total instance. So it is 7 by 14 into the entropy value plus the second value normal. How many normals are there? 7. How many are the total elements in the data set? 14. Into what is the entropy? 0.592. So this is the information of the attribute humidity. So now we are going to calculate the information gain for the humidity variable. It is given as before splitting minus after splitting. So the total information is 0.94, and for this humidity it is 0.788. So the total information gain for this variable is 0.152. We move on to the third variable. The third variable is temperature, and the fourth variable is windy. So if we calculate similarly, we get the information gain for temperature as 0.029, and for windy the information gain is 0.048. So we have summarized this. So what is the value of these information gain help us to understand? What does it help us infer? So we have to make a tree. We have to build a tree. So the tree has to have a root node. Followed by that it has to have a different branches. So out of these 4 variables, which variable is going to be the root node? To make that decision, we make use of the information gain. So the node which has the highest information gain